Good morning, dear students. How are you today? I hope you're fine and everything is fine with you. Now we're going to take the 24-hour clock. Today I want you to know a new information. Morning and afternoon, evening. You know that morning I have here AM. We use AM for the morning and PM for the afternoon. But do you know why we use AM as an abbreviation of what and PM stands for abbreviation of what? Let's see together. So I have here AM anti-meridian and here PM post-meridian. What's this? Anti-meridian, this means before midday, before noon, and post-meridian means after midday, after noon. So I know this is new information for you now. I have here a 12-hour clock. This is used by most of us and all over the world. It's most used here, the 12-hour clock. This is what I have here when the short hand of the clock points to 1, so it's 1 o'clock. Okay, after this, when I say the short hand here in 2, it's 2 o'clock. But I want to know, is it AM or PM? Okay, if you are in the morning, so here I say it's 1 o'clock PM. Yeah, it's in the morning, or afternoon, it's afternoon. So I said what now? Noon, afternoon. So here 12 is the noon. So here 12 is the noon. And then comes the afternoon. And here comes all the numbers after 12. This is called afternoon. Okay, let's see. So 1 here, 1 PM. It's afternoon. 2 PM, it's afternoon, until I go like this, then I get to the midnight. So here is the midnight. Okay, so after the midnight we are saying 1 AM. 1 AM, it means 1 in the beginning of the morning. I know it's dark, but here in the clock it means 1 AM. 2 AM, until I get to 12 here, the noon again. Okay, here we have a 24-hour system. A 24-hour system. It's a system, 24-hour clock. This is new one, but some countries and some people are used to do so. So I have here 12, 1, 2, 3, and so on until I get to 12. Okay, but they don't say 1 PM. What do they say? They say they don't overlap again. So after 12 here they say it's 1300, it's 1400, it's 1500. Okay, what's this? This means this is 3 PM. This means 14, it's 2 PM, and so on. So what should we know? What should we do to know here it's 3 PM or it's 15? Let's do it together. So here, when he says what's 7 PM on a 24-hour clock, what should I do? It's very easy. You just say 7 plus what? Plus 12. So I can do it easily by saying 7 plus 12, and it will give you, yeah, here I will search for 7. Yeah, here 7 is written here, 19, because I added 7 plus 12, it gives you 19. So here 12 plus 7 equals to 1900. It's called here 1900. So here the midnight from 00 to 12 midday, then from 12 here to 00 again midnight. Remember that AM and PM are not used with a 24-hour clock. Okay, when it's said that 21 and 10 hours here, so what time is it on a regular 12-hour clock? It's very easy. It's the contrast. So I will subtract 12 from the 21 hours. It will give me 9 here and the 10 minutes. Don't forget. Here I have on a 24-hour clock, it's 6:55. What time is it on the 12-hour clock with AM and PM? The answer will be 6:55 AM. Why? Because it doesn't exceed here 12. So the number when it's less than 12, so it will remain the same with AM. So to have a summary of what we have told now, AM occurs in the morning. It stands for ante-meridian, which means before midday. You can think of it as before noon. PM occurs in the afternoon and evening. It stands for post-meridian, which means after midday. You can think of it as afternoon. A 24-hour clock doesn't start over again after 12 noon. The next hour, which we normally think of it as 1 p.m., is 1300, then 1400, and so on. So here, if I have two analog clocks, I have 24 hours time here. I want to know. I have here, it's a sample one, 12 hours, and this stands for the 24 hours. So if I have here 1 p.m., so here I have 13. I added 12. Here I have 2 p.m. Here I have 14. Here 24 hours times also, yeah, so and so on. Here 3 p.m., 15, 16, and so on. So here, if I say what time for 9 a.m., 9, okay, what should we say now? AM remains the same. AM remains the same. Focus here. AM, keep it the same, but PM, just add 12. So AM, keep it the same here for the 24 hours clock, but the PM just add 12, and vice versa. If you want to convert from 2100 here hour in the 24-hour clock, and I want to convert it into the ordinary clock, the 12-hour clock, I just do what here? Minus, subtract 12, okay? Okay, to convert it to the PM. Okay, I have here 9. What do you think? Can I subtract from 9 to 12? So it's obviously it's AM. So here, he wants me to convert from 1800 now. Yeah, what should I do? It's greater than 12, so it's PM. This is my thinking. It's greater than 12, so it's PM. So subtract 12 from 18, it will give you 6, so it's 6 p.m. Here I want to convert from 10:30 p.m. to the 24 hours. What should I do? Yeah, I just here add 12. So what should we do? So in the 24 hours it will give me, yes, 30 plus 0, 0, here 30, 10 plus 12, 22. Here some steps converting from 12-hour times to 24-hour clock. The following simple steps will help you change a 12-hour clock to a 24-hour clock time. So if the hour is exactly 12 p.m., then simply remove the p.m. label. If the hour is 12 a.m., then change it to 00. If the hour is a p.m. time, then simply add 12 to the hour. Otherwise, the hour doesn't change if it's less than 10. Then add a 0 before the digit. The minutes and seconds never change when changing between 24 hours and 12 hours. So when I have 1:45 a.m., it gives you 1:45. Here, then 1:45 p.m. I added here 12. 4:20 a.m. 4:20 I just removed the a.m. 4:20 p.m. I added 12. 11:32 I just removed the AM. And according to the PM, what should I do now? I added 12. 12:07 AM. I just cancelled the AM. 12:07 PM. I just here also cancelled the PM. Okay, this is all for the lesson. For this lesson, moving to the other lesson, keep with me. Moving to the next lesson, I have here frequency diagram. Frequency diagram. Okay, in this example, I have ages of students in the class. I have here the ages of them. Okay, I want to draw a frequency table. As I told you before in the last week, so we can do a frequency table easily by writing here the age and the number at age. Okay, so we're going to know what to do now. So, alright, so what's the lowest age that we have here? Look with me. What's the lowest age here? Yes, 5. How frequent is the number 5 here? How frequent is the number 5? It means that how many times it appears. So 1, 2, yes, just 2 times. And here after 5 I write what number? 6. Okay, so how many times the 6 here appears? Just 1 time. Then 7, then 5, 6, 7, then 7, 1, 2, 3 and 4. Then after this we don't have here 8, so I write here 8 and 0 and 0. Don't forget to write 8 even it's not here. After this 9, it's repeated how many times? Let's see. 1, 2, 3 and 4, just 4. Then 10, just 1. Then 11, I don't have here 11, so write the 11, don't forget, then write 0. Then write the 12, which is repeated how many times? Just 2 times. So this is the frequency table. Representing the frequency table on the, yeah, I can hear you, the dot plot. It's very easy. Okay, I know that here 5 here, the students in my class that are 5 years old, they are 2. Two students are 5 years old. Okay, for 6 years old, just 1. For 7 years old, just 4. If you write it here, it's very obvious here. You would have also sent it here that I have for the 7 years old, 4 students at that age. As I told you before, the range is the difference between the maximum and the minimum. Okay, I have here the maximum here 12 and the minimum 5. So 12 minus 5 will give me 7. This is the range. Okay, how many older than 9? How many students here older than 9? What do you think by your eyes? By looking at the dot plot. Here are the 9. I want to know how many students older than. So by your eyes, what do you see? 1, 2, 3. And we care about how many are older than 9. I want to know. Older than 9 from the dot plot, 1, 2 and 3. Right? Okay, can you see it now? Okay, from the table here, can I know? Yeah, obviously. After 9 here, I have 10, 11, no 1, 10, 1 student for 10, and 0 for 11, and 2 for 12, so 1 and 2, 3. So it's the same as I told you before. Looking for this histogram, okay, I have here from the time, okay, the time here denoted by T in minutes, and the frequency from 5 to 10, from 10 to 15, from 15 to 20, from 20 to 25. So from 5 to 10 I have 16. From 5 to 10 I have what? 16. Go up until I reach 16 here. Okay, from 10 to 15, from 10 to 15 is 22. So I go up until I reach 22. Okay, then I have from 15 to 20, 11. From 15 to 20, 11. Go up until I reach 11. And here from 20 to 25 is 1, just 1. This is called a histogram. You know that histogram differs than the bar graph because the bar graph are separated, but here in the histogram it's what? Yes, it's connected together. Moving to another lesson. Okay, frequency tables and frequency diagrams. Again, when a lot of data needs to be sorted, focus with me. One of the most efficient ways to use a frequency table. Okay, it's important to consider the sizes of groups. Okay, when sorting data into a frequency table. Example to know why we're using this frequency table here for representing these data. So for this example, Megan owns a bakery. She counts the number of customers she has each day at lunchtime on 30 consecutive days. The results are shown here. Can you see the results here? Yeah, lots of results here, see. So using this data in list form could be time consuming, and with a large set of data it may lead to mistakes or mistakes. A group frequency table would help to display and give an overview of the data. So the smallest number is 6. The smallest number is here 6. And the biggest number is 21. So groups that have a width of 5 are reasonable. This will give what? Let's see. Okay, again, using these data in list form could be time consuming, and with a large set of data it may lead to mistakes or miscalculations. Okay, miscalculations. A grouped frequency table would help to display and give an overview of the data. Okay, I will enlarge this. Okay, so the smallest number here is 6 and the biggest number is 21. So groups that have a width of 5 are reasonable. This will give 4 groups as shown below. Of course, smaller groups would be more accurate, but there may be too many groups too to show up any pattern in data. Let's see. We have here from 5 to 10. From 5 to 10. If you return back to the table here from 5 to 10, if you count from 5 to 10, let's see. In the first here column we have from 5 to 10, 1 and 2. Yeah, and so let's here count these in these columns from 5 to 10. I have here 1, 2, right, 3, 4, 5. I'm taking 10 with me because I said from 5 to 10. So I have here 5. Going to the other slide here. So I have here I represented by tallies. So I have here 6. So I have here 6. Okay, I counted 6 or what? Again please. So 1, 2, yes, from 5 to 10, 1, 2. Here I have 3, 4, 5. Okay, and 6. This one. Yes, this one. So I have here 6 from 5 to 10. Then from 11 to 15. If you count from 11 to 15 from the table, you'll find they are 14. From 16 to 20, so they are 9. From 21 to 25, because it's just one, I will go and see it. Yes, from 20, I said from what to what again, please? From 21 to 25. From 21 to 25. Let's search 21 to 25. So go from 21 to 25. Again here, yes, I found it here. It's 21. It appears just one time, so 1. I write here 1. Okay, after that, frequency diagrams. A frequency diagram, often called a line chart or a frequency polygon, shows the frequencies for different groups. The frequency chart below shows the results of the table. To plot a frequency polygon of groups of data, plot the frequency at the midpoint of each group. Let's see together. As we see here, the frequency diagram here, I have often called a line chart, as I told you before, or a frequency polygon. Okay, we have said this before. So here I have frequency and number of customers. Okay, 5 to 10, we have said that 6. I can remember now. 5 to 10, 6. Then from 11 to 15, 11 to 15, let's go back and see it together. 11 to 15, yes, we have said 14. So going to this, okay, I have here 14. From 16 to 20, going back and see, from 14 to 20, 16 to 20, I have here 9, and then 21 to 25, just 1. So here my chart or my graph show me here, yes, just 1. So this is what a kind of frequency diagram. Okay, I know it's very interesting now. Bar charts, a bar chart like a frequency diagram shows the frequency of events occurring. The height of the bar is the frequency. A simple bar chart may look like this. So it's very simple like this. Comparative bar chart. Okay, here this is number of customers here, as in example 1. 5 to 10, it gives me 6. 11 to 15, it gives me 14. 14, looking back, 14, yeah, 14. Then from 16 to 20, it will give me 9, and then 1. Showing here, yes, it gives me here 1. This is the bar chart. All the charts give me and represent the same data. The data here doesn't change, okay? From one chart to another, it doesn't change. Moving to the comparative bar chart, let's go. Comparative bar charts. Bar charts may be needed to compare data. Okay, the following frequency table shows the information for the number of pets owned by class. So here I have boys and girls. Yes, of course we have boys and girls. So number of pets, 1 pet, 2 pets, 3 or more. Okay, boys here. Boys have no pets. Boys that have no pets, their number, I have 2 boys have no pets. 4 boys have 1 pet. 2 boys have 2 pets. 3 or more pets, 3 boys have 3 or more pets. So here for the girls, 3 girls have no pets, 3 here girls have 1 pet, 2 girls have 2 pets, 1 girl have 3 or more pets. Wow. So a comparative, it means that you are going to compare between 2 categories. So can show this information, a key that shows which bar represents which data is necessary to be able to read the bar chart, the bar chart properly. So I have here, as you see here, I have here the green and the pink. The green stands for boys, and yeah, of course the purple one for girls here. So I have here 2, yes, 2 for the boys and 3 for girls. I have here 4 for boys, 4 green, and 3 purple, wow, for girls, and so on. Okay, this is so amazing to draw charts to represent the data. And here the green for boys and the pink or purple for girls, it must be written here as a key. Okay, do you remember the key? Yeah, the pictograph. Open your eyes, the pictograph. Oops, it's here, pictogram. A pictogram shows the frequency of events using what? Pictures. Two pictures. It comes from the name. A key that shows what each picture is worth is needed to be able the key, okay, to read a pictogram properly. So example here, 20 pupils were asked about their favorite type of film. The table shows their responses. Let's do it. Horror 3, action 7, Romance. 4. Comedy. 5. Other. 1. Other what? What about other here? I don't know. So this can be shown on a pictogram. Okay, let's see together. Okay, this is the key, as I told you before in the other sessions. Yeah. This stands, this picture, please focus, concentrate here. This picture stands for 4 people. Okay? Okay, and this one stands for 2 people. And this picture, 3 people. And this picture, 1 person. Yeah. So here, it's very important to know that the full one, 4 people. Half of the TV picture, I don't want to tell you half of the TV because some of you take half by numbers. I want you to know it by pictures, please, for God's sake. It's pictograph. Okay, then the next lesson, focus with me. The next lesson, I have put all the lessons in just one YouTube to be easy to record it, my dear students. So pie graph, as we have taken lessons about pie graph on the last week, so we're going to complete it now. So pie charts, what a pie chart is? A chart represented by a circle. It shows the proportion of each group at a glance. Remember that there are 360 in a circle, so each group in the pie chart will be a proportion of 360. A survey, remember, survey of the number. Okay, a survey here. Yeah, a survey of the number of people traveling in a vehicle is taken. Okay. So the results are in the table below. Okay, people traveling in a vehicle. I have here the frequency. So 1 person, 120 times. 2 people, 40. 3 people, 13. 4 people, 5. 5 or more, 2. Total, okay, the total here 180. So to draw a pie chart for this data, find the proportion of 360. Give me the percent, for God's sake. So okay, people traveling in a vehicle here, frequency and calculations and angle, focus. These are the steps. 1 person, I have here 1 person, frequency 120. Okay, 120 over what? Over the total. Focus, open your eyes and leave everything with your hands. So focus here. So 1 person, 120 over the total. So 120 over the total times what, miss? Times the 360. Why 360? Because I am doing what I'm drawing in the pie chart. So 120 over 180 times 360 gives you 240, the angle here. So moving to the other slide. Okay, here 1 person, as I told you here, the calculations of it. Look with me, people traveling in a vehicle. I need you to do this table and this pie chart to draw it. So 2 people, 40 over what? Yeah, of course, over 180, the total. So over the total times what to give me the angle? I know the total angle is 360 in the circle, so it will give me 80 degrees. 3 people, 13. Yes, I will take the 13 over 180 times 360 and it will give me the angle 24 degrees. And 5 over 180 times 360, the same, and this the same also. Look, 4 degrees, only 4 degrees here. So I have here, I draw by using I'm using here the. So here to draw the angles, I have to use my protractor. Don't forget to use your protractor. After doing what? Just draw a line here and put your protractor in the center of the protractor here, and put the center of your protractor here, the protractor, and put the center of the protractor here, and then draw the angles. So you will get the 240 degree which have here one person for 240 degree. Then for the 80 degree I have two people, here the 80 degree, and then here the three people in what, the three people in the 24 degree. And here for the 10 degree I have how many? Yeah, I have here 4 people in the 10. And then I have here in the 4 degree, I just have here in the 4 degree 5 or more students. Okay, so moving to the other slide now, as drawn here. It's okay. So by this we have covered all the week, all the lessons of the week. Study hard from the PowerPoint presentations, from the YouTube presentations. Do your assignments on Excel and send them back to me on the folder of in the Google Classroom. Thank you for listening, dear students. Have a nice day.